if a function is continuous on an interval and it changes sign, either from negative to positive or from positive to negative, it must cross the x-axis somewhere between a and b. By crossing the x-axis, we mean an intercept or a 0 or f of c equals 0. Very powerful, but only for continuous functions. One more time, if the function is continuous on an interval and it changes sign, either from negative to positive or the other way, from positive to negative on this interval, it cannot jump over 0. It has to cross the x-axis. It must have a point where the function is 0, or it has an x-intercept, or it's a root of the function. Does it make sense? So here's an example. We can go back to the book, or just say natural log x equals 3 minus 2x. So this is an equation. So we cannot solve this equation by hand. We have no tools to show this, to find the solution or solutions. Later on in chapter 4, we will talk about a very powerful theorem called Newton's theorem. And that will help us to solve this equation, as many solutions as it has, with any accuracy that we want. 8 digits, 7 digits, 10 digits. Okay? We are limited because we are somehow to the number of digits because of the graphing calculator. But at this point, we're not asked to determine the solutions. No, we're asked to find where, if it has solutions, where is at least one. Okay, if I know how to show where it is one, then I can show all the others. Find where there is at least one solution, if there is any. So first of all, I have to find a unit interval. So please don't say there is a solution between 0 and 10. That doesn't mean anything. You have to say there is a solution between 7 and 8. Or there is a solution between -5 and -4. It has to be a unit interval, or smaller, but not bigger than 1. A solution between 0 and 10 is not acceptable. Okay, my first step is I have to create a function by moving everything to the other side. That's okay. If I solve this equation, or I solve the equation natural log x minus 3 plus 2x, it's the same thing. So I have natural log x. I'm going to put it in some sort of order to x minus 3 equals 0. So then this is my function. Again, if I solve this equation or if I solve this equation, the solutions are identical. I only moved this term and this term to the other side. That's all I did. I changed their signs. Let me turn this off, sorry, because it's a colleague of mine and she can wait. Okay, so I'm given f of x. I have f of x, and I will, so this, natural log x, 2x, and 3. So first of all, this is a polynomial function, continuous as we know everywhere on -infinity to infinity. There is a little bit of a problem with this, but I know the graph. Can anyone tell us where is this function continuous, or where it's its domain? Anyone?
Is it all positive?
Very good, thank you. Who said that?
Mark.
Thank you, Mark. Great job. So obviously, I can say now that f of x number one, continuous, definitely on 0 to infinity. And number two, I have to really find an interval where the function hopefully changes sign. So at this point, I'm going to share my screen. I have my calculator ready. We will punch in, sorry guys, we will punch in y equals, clear anything you have. We will punch in natural log x. Are you with me, everyone? Please, I don't want to lose anybody. Plus 2x.
Yes.
Plus 2x and minus 3. At this point, we're going to go to second and table. And I'm going to start punching in numbers. I cannot punch in 0. So I'm going to punch in 1. It's already there. I get -1. I'm going to punch in 2. It's already there. I just put in the function. And it's positive. That's all I need. So I will stop sharing. Sorry, I have to move you again. So I will say 1, 2, f of 1, that was negative. F of 2 is positive. So from these, what do we conclude? 10, will you get us started? What do we conclude?
You can conclude that there is a c that is going to be equal to 0.
By IVT, there must exist a c in the open interval 1, 2 such that f of c is 0. We do not have the solution. IVT does not help us find C. It helps only to find a unit interval where there is a solution. But this is extremely helpful. So now I have to come back and say here that f of x is continuous, obviously here, but what I really need is the interval 1, 2, the interval that I just determined. This is more than that, but I only need 1, 2 because that's where the discussion happens. So IVT gives us an interval. It tells us the solution must be here, but it doesn't tell us which one. Okay, I know I have only 1 minute left. I will not be able to finish that problem 48 that I promised. So I'm going to share my screen just for 1 second. Just don't let me forget. So I want to show this because it's an important problem. And 2.5 is finished. So I'm hoping that by Thursday, 2.4, 2.5 are completed, please, so you can ask questions, please. So 2.4 and 2.5 are done. I do owe you a problem from 2.5, which is a very important type of problem